Write all the other trigonometric ratios of angle A in terms of sin A. So here, let sin A, I'll consider it as K. Let sin A, I'll consider it as K, so I'll write K by 1. So sin theta ratio is opposite to theta by hypotenuse. So here if we'll take a right angle triangle, I'll name it as ABC. ABC, right angle at B. Angle is at A. So this will be opposite to angle A. I just looking at opposite to angle A. This is adjacent to angle A, and this one is hypotenuse. So here I consider opposite as K and hypotenuse is 1 because just I consider K, so I can write by 1. Now I'll apply Pythagoras theorem to find AB square. So Pythagoras theorem, AC square hypotenuse square equals sum of the squares of other two sides. So AC is 1, AB I need to find, BC is K, so K square. So 1 minus K square is AB square. Square if I'll send to the other side, under root 1 minus K square is AB. So AB is under root 1 minus K square. So all the ratios in terms of sin. So already sin is K. So I'll start writing from cos. Cos A. Cos ratio is adjacent by hypotenuse. Adjacent is under root 1 minus K square. Hypotenuse is 1. So wherever K is there I need to write sin. 1 minus K is sin square A. Next ratio, tan, sin cos, then tan. Tan is opposite by adjacent. Here see, if you'll see the opposite, it is K, adjacent is under root 1 minus K square. So I'll write here K by under root 1 minus K square. And wherever is K, there I need to write sin A. Sin A by under root 1 minus sin square A. Next, in the same way, cot A. Adjacent by opposite. Adjacent is under root 1 minus K square, by opposite is K. So under root 1 minus K is sin, so sin square A by sin A. Sec A is hypotenuse by adjacent. So hypotenuse is 1, adjacent is 1 minus K square. So 1 by under root 1 minus K, but K is sin A, so sin square. Cosec A, hypotenuse by opposite. Hypotenuse is here 1, opposite is K, so 1 by K, K is sin A. So all the ratios, sin, cos, tan, cot, sec, cosec, all we wrote in terms of sin. Write all the other trigonometric ratios of angle A in terms of cos A. So I need to write all the ratios, sin, cos, tan, cot, sec, cosec, all in terms of like cos A. So I'll consider here, I'll solve this problem by using Pythagoras. Cos A, Pythagoras theorem, equals K. So I'll write cos K by 1. Cos theta ratio is adjacent by hypotenuse. So if I'll take a right angle triangle, ABC, right angle at B. So now angle is at A, so this is opposite to angle A, adjacent to angle A, hypotenuse. So here adjacent is K and hypotenuse is 1. If we'll apply Pythagoras theorem here, AC square equals AB square plus BC square. Hypotenuse square is equal to sum of the squares of other two sides. Hypotenuse is 1, AB is k, BC square. So 1 minus k square is BC square. Under root 1 minus k square is BC. So BC value is here under root 1 minus k square. Now here I need to write the other ratios. That is nothing but first one, like sin A is opposite by hypotenuse. So opposite is 1 minus k square, hypotenuse is 1. So but wherever k is there I need to write cos A. So 1 minus k square, k is cos, so 1 minus cos square A. Next, cos already we have, so I'll write tan. Tan A is opposite by adjacent. Opposite is 1 minus k square, by adjacent is k. So wherever it is k, there I need to write cos. 1 minus cos square A under root by cos A. Next, cot A is adjacent by opposite. Adjacent is k, by opposite is 1 minus k square. So k, wherever k, there I need to write cos A. So cos A by under root 1 minus cos square A. Then sec A, sec theta ratio is hypotenuse by adjacent. Hypotenuse is 1 and adjacent is k. So 1 by cos A. So wherever is k, just write cos. Next, cosec A. Cosec theta ratio is hypotenuse by opposite and reciprocal of sine. But hypotenuse here is 1 and opposite is under root 1 minus k square. So 1 by under root 1 minus k is cos. 1 minus cos square A. Write all the other trigonometric ratios of angle A in terms of tan A. So here I'll consider tan A, I'll consider it as k. I'll write k by 1 and tan theta ratio is opposite by adjacent. So here instead of identities I'll solve this problem by using Pythagoras theorem. So here I'll take a right angle triangle ABC, right angle at B. So angle is at A. So this side will be like opposite, adjacent and opposite to 90, which is hypotenuse. So here opposite is k and adjacent is 1. So I'll apply Pythagoras theorem to get the value of AC. So hypotenuse square equals sum of the squares of other two sides. Here AC square, AB is 1 square, BC is k square. So AC equals square if we'll take to the other side under root 1 plus k square. So hypotenuse is under root 1 plus k square. Now I need to write all the ratios. So sin A is opposite by hypotenuse. Opposite is k. Hypotenuse is 1 under root 1 plus k square. So k is tan theta. So here I'll write tan A under root 1 plus k. K is tan square A. Next, cos A. Adjacent by hypotenuse. Adjacent is here 1 and hypotenuse is 1 plus k square. 1 by under root 1 plus k. In place of k I'll write tan square. In place of k I'll write tan, so k square is tan square A. Next, tan is already we have tan A, k. Tan A is tan A itself. Then I'll go for like cot. Cot A is adjacent by opposite. So adjacent is 1, opposite is k. So in place of k I'll write tan A. Next, sec A is hypotenuse by adjacent. Hypotenuse is under root 1 plus k square by 1. So under root 1 plus in place of k I'll write tan A. So k square will be tan square A. Next, last ratio, cosec A. Cosec A ratio is hypotenuse by opposite. So hypotenuse is 1 plus k square under root, by opposite is k. So wherever it is k, just write tan. 1 plus tan square A by k, which is tan A. So here all the ratios, sine, cos, cot, sec, cosec, all we got in terms of tan. Write all the other trigonometric ratios of angle A in terms of cot A. So here I'll solve this problem by using Pythagoras theorem. So let cot A, I'll consider it as k, and I'll write k by 1. Cot theta ratio is adjacent by opposite. So I'll take a right angle triangle, and right angle at A, if I'll take A here, angle is at A, right angle at B, C here. So this side will be like BC will be opposite to angle A, AB will be adjacent to angle A, and AC is opposite to 90, its hypotenuse. Now I consider cot A as k by 1, adjacent is k, opposite is 1. So I need to find hypotenuse, so I'll apply Pythagoras theorem. Hypotenuse square equals sum of the squares of other two sides. So AC square, AB is 1, AB is k, BC is 1. So AC square is k square plus 1. Square if we'll take to the other side, root k square under root k square plus 1. So AC value is under root k square plus 1. Now I need to write all the ratios. First I'll take like sine A, which is opposite by hypotenuse. Here opposite is 1, hypotenuse is under root k square plus 1. So wherever it is k, just write cot A. So k square cot square A plus 1. Next, cos A. Ratio is adjacent by hypotenuse. Adjacent is k. Hypotenuse is under root k square plus 1. K in place of k cot A by under root k square, which is cot square A plus 1. Next, tan A is opposite by adjacent. Opposite is 1, adjacent is k. 1 by k in place of k cot A. Next, cot A already we have, so I'll write sec A. Sec theta ratio is hypotenuse by adjacent. Hypotenuse is under root k square plus 1. Adjacent is k. So wherever it is k, just write cot square, cot A. So k square will become cot square A plus 1 by k is cot A. And the last ratio, that is cosec A. Cosec A is hypotenuse by opposite. Hypotenuse by opposite. So hypotenuse is under root k square plus 1. Opposite is 1. So under root in place of k cot. So k square will be cot square A plus 1. So here all the ratios, sine, cos, tan, sec, cosec, all I wrote in terms of cot A. Write all other trigonometric ratios of angle A in terms of sec A. So here, see, instead of using identities, this problem I'll solve with the help of Pythagoras theorem. So I need to write all the ratios in terms of sec A. So I'll consider, let I'll consider sec A, I'll consider it as k, and I'll write as k by 1. And sec theta ratio is hypotenuse by adjacent. Hypotenuse by adjacent. So here I'll use a right angle triangle. Right angle triangle with ABC. Right angle triangle ABC, right angle at B. Now angle is at A. So this side is opposite to angle A. This is adjacent to angle A. And this is opposite to 90, so it's hypotenuse. So sec theta ratio is hypotenuse by adjacent. So I consider hypotenuse as k and adjacent as 1. So this is k, this is 1. I'll apply Pythagoras theorem here. AC square equals AB square plus BC square. AC is k square, AB is 1 plus BC square. So k square minus 1 is BC square. So under root k square minus 1 is BC, because square falls into the other side root. So BC is under root k square minus 1. Now we need to find all other trigonometric ratios. So first I'll take sin theta. Sin A. Sin A is opposite by hypotenuse. So opposite is under root k square minus 1. Hypotenuse is k. So in place of k, just replace with sec A. So secant square A minus 1 by sec A. So this is sin. Next I need to write now cos. Cos A is adjacent by hypotenuse. Directly you can write reciprocal, but here I am using Pythagoras theorem. So adjacent is 1, hypotenuse is k. So 1 by k, wherever k is there you should write sec A. Next tan. Tan is opposite by adjacent. Opposite is under root k square minus 1 by 1. So under root, wherever k I told, just write secant square A minus 1. Cot A. Cot is adjacent by opposite. Adjacent is 1, opposite is under root k square minus 1. So 1 by under root secant square A minus 1. Next, sin, cos, tan, cot, sec. Already we have sec will be as it is k sec A only. So I'll write cosec. Cosec A ratio is hypotenuse by opposite. So hypotenuse is k and opposite is under root k square minus 1. So wherever k is there, here k I'll write as sec A by under root sec square A minus 1. Wherever k is there, secant square A minus 1. So here this problem I solved with the help of Pythagoras theorem. Write all the trigonometric ratios of angle A in terms of sec A. So sec A I consider it as k. If the last write all the ratios in terms of sin A, then I'll consider sin A as k, then I'll solve the problem. Write all the trigonometric ratios of angle A in terms of cosec A. So here I'll solve this problem by using Pythagoras theorem. Let cosec A, I'll consider it as k. I'll write by 1. Cosec theta ratio is hypotenuse by opposite. So I'll take a right angle triangle ABC. If I'll take A over here, B here, C here, right angle at B, angle is at A, so BC will be opposite, AB will be adjacent, and AC is hypotenuse. Hypotenuse is k, opposite is 1. So I need to find AB. So I'll apply Pythagoras theorem. Hypotenuse square equals sum of the squares of other two sides. So k square equals AB square. BC is 1. K square minus 1 is AB square. Under root k square minus 1 is AB. So AB is under root k square minus 1, which is adjacent here. So now I'll write the other ratios. Sin A is opposite by hypotenuse. Opposite is from here, opposite is clearly from here, opposite is 1 and hypotenuse is k. So 1 by k, wherever is k, just write cosec A. Cos A adjacent by hypotenuse. Adjacent is under root k square minus 1 by hypotenuse is k. Under root k square is cosec square A minus 1 by cosec A. Wherever is k, just write cosec A. Tan A opposite by adjacent. Opposite is 1 and adjacent is under root k square minus 1. So 1 by under root, wherever is k, just write cosec. Cosec square A minus 1. Next cot A. Cot is adjacent by opposite. Adjacent is k square minus 1, opposite is 1. So under root, in place of a k cosec A, so k square is cosec square A minus 1. Next one, sec A. Sec theta ratio is hypotenuse by adjacent. Hypotenuse is k, adjacent is under root k square minus 1. So cosec A by under root cosec square A minus 1. So in this way, by using the Pythagoras theorem, we can write all the ratios in whichever the ratio you need. So in this question they asked like write in terms of cosec. So cosec A I consider it as k. And then I got all the ratios, sin, cos, tan, cot, sec in terms of cosec.